right, welcome. Where are we? Oops. All right, so welcome. Sorry about that. What is pH? So pH is something that you've probably heard of before. What it stands for, depending on who you talk to, is either potential hydrogen or the power of hydrogen. So depending on what textbook you're talking about, etc. Either one of those, oh my gosh, seems to work. So this is a formula to calculate pH, not on the Regents anymore. Could be familiar, could be important if you are going on to higher level chemistry. To calculate pH, you take the negative log of the H plus concentration. Remember that these brackets mean concentration. Okay, so this is kind of a useful little chart. As the H plus concentration decreases, OH minus or hydroxide increases. So low pH has a ton of H plus, very little hydroxide. Middle would have neutral, would have the same amount. And then as you continue on, higher pH is going to be up here. So the pH scale goes between 0 and 14. And 7 in the middle is our neutral. So to calculate pH changes, each jump on the pH scale is a 10-fold change or times 10. So if you are stronger in math, you should understand how logarithms work and how each change in logs is worth 10. If you're not as strong in math, just know each jump on the pH scale is worth a 10-fold change. So if we're comparing a pH of 3 to a pH of 4, pH of 3 you should know is more acid, more acidic than 4. How much more acidic? Well, this is one jump. So 4 to 3 is going to be times 10. So 3 would be 10 times more acidic. You could also say pH of 4 is 10 times less acidic. You can say that too. Compare a pH of 6 to 3. So if I have 0, 1, 2, 3, 4, 5, 6, etc. So I'm comparing 6 to 3. That's 1, 2, 3 jumps. Don't get confused. That does not mean it's 3 times less acidic or 3 times more basic. It's this jump is worth 10. This jump is worth another 10. Not adding, but multiplied. So 10 times 10 is 100. 10 times another is 1,000. So you could say pH of 6 is 1,000 times less acidic. You could also say it's 1,000 times more basic or more alkaline. You could say pH of 3 is 1,000 times more acidic, etc. So when you are comparing, you can talk about it from either angle. But it's important to note each jump is worth 10. Here is a calculation using the formula. So remember the formula is negative log of the H plus concentration. In this case, the H plus concentration is 1.4 times 10 to the minus 4 molar. So you would just plug in your calculator, negative log, this whole thing. If you want to do it in sign notation, let's see, 1, 2, 3, 4, if you want. And your answer should not be, I don't know, like 35 or negative 18. You know your answer should be within the regular pH range. So that should be between 0 and 14. So you get 3.85. And now pH does not have units, so you'll just say pH is 3.85. So the Regents may ask you to calculate pH given molarity. In these cases, simply move the decimal place until you get to a whole number 1. So for example, what is the pH of a 0.0001 molar HNO3 solution, which by the way, HNO3 is called nitric acid. If you didn't know that, it's on table K. So I could plug this into this formula, or I could just say, how many spots do I need to move the decimal place till I get to that whole number 1? 1, 2, 3, 4. pH is 4. Okay? Now I had that. Yeah, sorry, the thing's right over the answer. So pH is about hydrogen. pOH has to do with the hydroxide or the base. Since the scale goes from 0 to 14, your pH plus something called pOH has to equal 14. Water, Kw is the water constant, means that water, which is neutral pH, should have equal concentrations of the hydroxide and hydrogen ion concentrations at 25 degrees Celsius, which is room temperature. If you know H plus, you know OH minus. If the pOH of a solution is 8, is the substance acid or base? So I can't tell from pOH because I don't know that scale as well, but I do know pH. So if I say pH plus pOH has to equal 14, and I know that pOH is 8, that means that X has to equal 6. So the pH is 6. Now, since I am familiar with pH scale, I know that pH of 6 is an acid. Yes, it's a weaker acid, but it is an acid. I had all that. Oh well. So anyways, that's all there is to it. I believe this is in the next set of notes. All right, hope that helps. Take care.